So question 6, given that theta is measured in degrees and cosine theta equal 1 over root 5 and theta is between 180 and 360, use trigonometric identities to find the exact value of sine theta and tan theta. Given that cosine theta equal 1 over root 5 and theta is between 180 and 360. Keep this in mind. So the trigonometric identity that we know from pure 2 is that sine squared theta plus cosine squared theta is equal to 1 and tan theta is equal to sine theta over cosine theta. Sine squared plus cosine squared equal 1. This means that I can square both sides and it would be cosine squared theta equal 1 over 5 power 2. 1 power of 2 is 1. Root 5 power of 2 is 5. Cosine squared can be written as 1 minus sine squared. Negative sine squared will go to the other side and be positive sine squared theta equal 1 minus 1 over 5. 1 minus 1 over 5 is 4 over 5. To get rid of the square root sine theta equals to positive or negative root 4 over 5, which is positive or negative 2 over root 5, because root 4 is 2 and root 5 is root 5. Okay, which one are we going to choose? Positive 2 over root 5 or negative 2 over root 5? This will take us to the constraint that theta is between 180 and 360. Since the theta is between 360 and 180, we are going to reject this solution and sine theta will be equal negative 2 over root 5. Why is that? It is because the graph of sine theta goes like that. The positive part is between 0 and 180. This is 2 over root 5, for example. The line y equal 2 over root 5, because sine theta equal 2 over root 5, it is like solving two simultaneous equations. One is sine theta, y equal sine theta, and the other is y equal 2 over root 5. And when we equate them, it is like solving them simultaneous. The solutions will be between 0 and 180. Negative 2 over root 5 will give the solutions that are between 180 and 360. That's why this one will be rejected and sine theta is equal to negative 2 over root 5. Okay. Now part B, find tan theta. Tan theta is equal to sine theta over cosine theta. So tan theta is equals negative 2 over root 5 over cosine theta, which was given in the question. Cosine equal 1 over root 5. Plug in the calculator. Negative 2 over root 5 over 1 over root 5, which is negative 2. Tan theta equals to negative 2. Okay, this is part I, A and B. Now let's move to part double I, A and B, then part C. The height of seawater, H meters on a harbor wall, T hours after midnight on a particular day is given by this equation. H equal 4 plus 3 cosine 30 T minus 40. A sketch of H against T is shown in figure 2. Find the minimum height of seawater on the harbor wall. This is very easy. The minimum point for cosine graph is that we substitute the cosine by -1. So we can substitute this by -1. 4 plus 3 times -1 is 4 minus 3, which is 1. This is the minimum height. This is a way to look at it. The other way, look at the transformations. Look at the transformation happened. It is stretched by factor 3. So the maximum point now is 3 and the minimum is -3. Then shifted 4 units upward. 4 units upward, it will be 7. 3 plus 4 is 7. -3 plus 4 is 1. So the minimum point, the minimum height is h equals to 1. This is part double IA. Double IA. Part B, find the exact time of day when this minimum height first occurs. Alright. The minimum point in the cosine graph. This is cosine theta or cosine x. It should be at 180 degrees, right? But we have here a transformation on x. So we are gonna say 30t minus 40 equals to 180. Move the 40 to the other side and divide by 30. It is gonna be 220 over 30, which is 7.33. Find the exact time of day when this minimum height first occurs. This is the time after midnight, so it is gonna be at 7 a.m. and 20 minutes. 0.333 times 60 is 20 minutes. 0.3333 is 1 over 3 actually. 1 over 3 times 60 is 20 minutes, so the time is going to be 7:20 a.m. We can try the final answer here in this section, right in the space given below. Double I, part B. Alright, last part, part C. When t equal to t capital, as shown in figure 2, a boat enters the harbor when the height of seawater on the harbor wall is 3.5. Use figure 2 and the given equation to find the value of t to 2 decimal places. Okay, so t capital is right there. When we solve 4 plus 3 cosine 30t minus 40 equals to 3.5. We are solving this curve simultaneous with line y equal 3.5. Let's move to the space down, part C. Part C. Move the 4 to the other side. It is going to be 3 cosine 30t minus 40 equal negative 0.5. The 4 goes to the other side. Divide by 3. It is going to be cosine 30t minus 40 equals to negative 0.5 over 3, which is negative 1 over 6. Cosine inverse negative 1 over 6, shift cosine negative 1 over 6 degrees is 99.59. So this is 30t minus 40 equals to 99.59. 99.59. The calculator always gives the first solution. So this is the first solution. We still haven't got the t. We'll move the 40 to the other side and divide by 30. But we want to say that this solution is the first one. The second one is 360 minus 99.59. 99.59. This is 99.59. And the t is plus 360. This is 360 plus 99.59. So if you want to cut it short, solve 30t minus 40 equal 459.59. Move the 40 to the other side, it will be 30t equals to 499.59, and t will be equal to 499.59 divide 30, which is 16.65. t is equal to, this is t capital actually, equal to 16.65. This is rounded to 2 decimal places as required. Round t to 2 decimal places. Hope everyone understood the question. I know it is pretty hard, but yani, you can get it. Let's move to question 7.